Hey there, brilliant people. How are you today? So today I'm going to discuss about the field of view of an observer. And in field of view of an observer, you have a plane mirror, and there are three objects which are kept at some distances away from the mirror. So this object is at a distance 4 meter away from the mirror, and I have measured this distance in a perpendicular way. So exactly 4 centimeters behind you have the image of object O1. In the same way, this object is at a distance 3 centimeters. So behind the mirror at 3 centimeters you are having an image. Again, this object is at 5 centimeters away, and you are getting the image 5 centimeters behind the mirror. Now the question is, if there is an eye which is located say over here. Now can this eye see all the images, or one image, or two image, or none? So how can you actually find that this eye can see how many number of images? So for that you require to construct a field of view of an observer. So what you need to do is, you need to take two rays, actually not rays, two lines which come out from the middle of the eye, and they are going to strike the eye, the edges of the mirror like this. Here dotted line, this is the edge of the mirror, and now construct a solid line like this. Again another line that should come out of the eye, and it should touch the edge of the mirror, and now you extend this line forward like this. Now this area people is the area which is called the field of view of an observer. Remember, these are not the rays, right? So these are just two simple lines which are coming out of the eye and striking the edges of the mirror and being carried forward. Now as you can see that this image falls in the field of view of an observer. So this image can be seen. So that means the object O1, its image can be seen by this eye. And if you want to confirm, we can do that. You can see that there are many rays which are going to hit and then finally come to the eye. As I previously said in one of my videos, that if the reflected rays are coming into the eye, you can see the images. Now let's check for this one. See, if the ray from here, if they strike like this, they are going to pass the eye. If the rays hitting the upper part, they are going to go in the upward direction. If the rays going straight, they are going to go straight after reflection. So none of the rays after reflection, they are going to come to the eye. You may feel that no, that there would be some possibility that it would hit like this, but it is not possible, because if you draw the normal, and if you make the angle of incidence at the same angle down, it would be passing away from the eye. In the same way, these two images are of these two objects, and you take out any ray after reflection, it would never enter the eye. All the rays which are coming from O2 and O3, straight after reflection, they are going to rebound, right? So let me construct one such ray. Just imagine any ray which is striking like this. Since the angle of incidence is 0, it would continue to go in this direction, so this reflected ray is not going to enter. If the ray hits over here, it would go like this. If the ray going in the upward direction, it would be going in the upward direction. So none of the rays from O2 and O3 are going to enter inside the eye after reflection. Yes, but there are several rays from O1, after reflection it will come to the eye. So all those images which are in the field of view will be visible, and their reflected light will enter into the eye, right? Now this concept of the field of view of an observer definitely depends upon the size of the mirror. If the size of the mirror is larger, then of course the field of view of an observer will increase. If the eye is very close, then also the field of view will increase. So let me draw an eye somewhere over here. So now what is going to happen is, from the middle of the eye, I am going to take out two rays, and now these two rays are going to touch the mirror and finally go like this. Go like this. So as you can see that if the eye is comparatively nearer, more portion behind the mirror, now this part will also be included. So all the images will be seen now. So the distance from the mirror of an eye matters in the field of view. Then size of the mirror also matters. And now let's take the third case wherein I have the same diagram, but I have shifted only one object nearby. Now just imagine that if the eye is somewhere over here, more tilted like this. So I was previously in somewhere over here. Now I am bringing the eye comparatively at the bottom of the mirror. Then two straight lines coming out of the eye, hitting the edges of the mirror, striking the edges of the mirror, being carried forward on the other side. And as you can see that this part is the field of view of an observer and no images fall into that. So under this situation, the eye will not be able to see any of the images. So that means the field of view of an observer depends on the size of the mirror, the orientation of the eye, and the distance of the eye from the mirror. So hopefully guys you have understood this explanation, and do subscribe to my channel if you have not done so, and if you have any doubts please do comment in the comment section. Remember, you have to subscribe to my channel because there is more interested learning coming on the way. Thank you for watching the video.